Hello and welcome to the EPRI Current. I'm your host, Samantha Gilman, and today we'll be talking about wildfires and resilience. I'm joined by two EPRI researchers. First, Erik. He is a program manager in our Integrated Planning and Operations Program team. And then I'm joined by Agatha Kazdan, who is a principal technical leader in our Advanced Buildings and Communities group. Thanks to both of you for joining today. So before we get into our topic, I first want to let our listeners get to know you two a little bit more. So let's start with Erik. Why don't you tell us a little bit about who you are and what you do at EPRI?
Sure. Thanks, Samantha. I'm very happy to be here. So my role at EPRI is I manage our research area on wholesale electricity markets and integrating emerging technologies onto the power grid. So focus of that is quite a bit different than the topic of today, but always excited to work on lots of new topics.
Thanks. And Agatha, tell us a little bit about your work here at EPRI.
Yeah, sure. So my name's Agatha Kazdan, and as Samantha mentioned, I work in the Advanced Buildings and Communities team, and I do research and demonstrations addressing building decarbonization solutions that are scalable and cost-effective.
Great. So we have a bit of an interesting episode today. Typically, we talk with our EPRI researchers and industry thought leaders about particular pieces of research. And we'll certainly get to some of EPRI's research later in the episode, particularly from Agatha talking about our work in advanced buildings and communities. But first, we're going to start with a more personal story from Erik to give some context to a conversation we have here a lot at EPRI around climate resilience and planning for the grid of tomorrow, planning for the weather of tomorrow as extreme weather events continue to increase. And one of those extreme weather events that we see more and more of, unfortunately, is wildfire. Erik was personally impacted from one of the large wildfires several years ago in Colorado, and we'd like to hear his story on what happened and what has happened since. So Erik, now that you've experienced, unfortunately, something that's not so uncommon these days, firsthand how wildfire can impact individuals, families, and communities, can you tell us a bit about your story?
Yes, sure, Samantha. So on December 30th, 2021, the Marshall Fire happened in Colorado. We lost our home, virtually all of our belongings, and most unfortunately, our two little cats. And if you see a cat in the background, that's a new cat that has helped us fill that gap. The home was burned to the foundation. Steel beams were warped like pretzels. It was 120 mile per hour winds, 1,100 homes lost, including our entire neighborhood. And many of the homes were burnt from the inside and very quickly. So horrific event, really impacted mine and my family's life. But not to overuse the saying, but we really had a phoenix rising kind of situation. Really did turn this terrible situation into something I think that's very positive. So we are building a unique fire resilient electrified passive house and hopefully moving in this summer. So very excited about that and very excited about just learning about how to do that and the building science behind it.
So you mentioned you're building a passive house. Can you tell us what that means?
Sure. And again, I'm not the expert, but hoping to learn more and more about what this means. Passive house is of the highest international certification for energy efficiency. There are very few of these around. I hopefully not quoting a wrong number, but I think there was less than 20 in Colorado that were actually certified as a passive house. So it's not common. But it's essentially 90% more efficient than a kind of a standard home that's maybe been around for a while, maybe 70% less energy than a new, a home built this year with the standard 2021 building codes. It's electric only, super insulated, airtight. There's really almost no air exchange between the inside and the outside. Triple pane windows. Kind of a useful example I like to give is one of our consultants, when they do this thing called the Passive House Challenge. In the winter, they don't use heating, and they see, after a long time, what happens, what's the temperature difference. He had it, no power for 7 days, 20 degrees outside for most of that period. I think they never got below 60 Fahrenheit. So just really unique, really efficient, and of course, fire resilient as well.
So the topics you were just discussing may not be in your wheelhouse at EPRI, but they're definitely in Agatha's, and it's something that we do R&D on here at EPRI as far as energy efficient housing, appliances, fire resistant housing. Agatha, can you tell us a bit about that work that EPRI does and the energy efficiency of the built environment?
Yeah, absolutely. So as I mentioned, we have a portfolio of building demonstrations that are looking at decarbonization pathways, and we study the impact at a local and system level. And increasingly, that includes looking at resiliency. We place a special emphasis in our group on disadvantaged groups who, frankly, are bearing, the brunt associated with legacy fossil fuel infrastructure and can't necessarily afford to make the upgrades that would save them money, energy, improve their comfort and their health. And due to the kind of increased prevalence, as you mentioned earlier, of extreme climate events, we're more systematically including resilience into that scope. And to be clear, we don't view resilience as a separate agenda from energy efficiency anymore. And I think that Erik, in describing his decision to pursue a passive house, exemplifies that really well, kind of a holistic approach, I should say. We view, for example, some, research and demonstrations I'll talk about in just a bit. We view the hardening of the home as important to make them more habitable shelters for people in the case of an extreme event or outage, just as Erik, demonstrated, describing how long the interior of the home was able to maintain livable temperatures or survivable temperatures at a time when it was very cold outside. When you build homes at that level, they also contribute to overall system reliability, even when there isn't an extreme event. In terms of requiring less power from the grid and less power during times when the grid is particularly constrained. To that end, in some of the demonstrations that I'll talk about later, we are improving the insulation and air sealing, installing heat pumps and renewables, and adding grid interactive controls to ensure that our homes are not only very energy efficient, but good grid citizens as well. Just generally are more resilient structures.
So to get a sort of a level deeper on the details of the technologies that you're both referring to, both Erik in your new home and Agatha, the research that we do. Erik, can you share some of the technology decisions you made for this new passive house, whether it be heat pumps or any sort of DER? I know it's not coming from necessarily a research point of view from you, Erik, but I'm intrigued by what technologies go into a passive home or are an option for a passive home.
Yes. So, in terms of some of those technologies, one of the really interesting things is, so obviously it's electrified, so we are using air source heat pumps. But just sort of the level of that you actually need to heat this kind of a home, it's, obviously you're in a really big sweater. So when you're in a really big sweater, do you need much else to keep you warm? And so one of those things is, it's just very small heat pumps. They're mini splits. In total, probably, we have one per floor. about a very small device that is needed. And the other big important sort of HVAC appliance of passive house is your ventilation system. So we have a heat recovery ventilator. That's really to exchange the air from the outside and the in. So taking air from the kitchen or the bathrooms and putting that out, and then bringing fresh air in from the outside because of how airtight it is. So we'll actually have the second of these devices for this one particular company, which is about 90% efficient, installed in America. It's actually a Dutch company that does it. Our neighbor had the first one installed in America, and I think we'll have the second. It actually just saw it the other day, so very excited. At the moment, we're not putting solar on the roof, but part of that is just to understand what our consumption is. So, not having to overbuild. It's just, there's not a lot of data that we have yet on how much we'll actually need to go net zero, because we're so close to, we're using so little energy. Having a vehicle and that sort of thing will add to it.
We'll have to have you back in a year to see how the house went and how the technology is performing. It's really interesting stuff. And for those of you who are listening, if you're more interested in heat pumps, we actually did a heat pump episode this past November with our heat pump expert, Ron Dimitrovic, who is also part of Agatha's sector here at EPRI. So if that's a topic of interest, go check out that episode. So back to you, Agatha. I'd like to hear more about what you were alluding to earlier, some projects that EPRI is working on with energy efficient and possibly fire resistant housing. Can you tell us more about that project?
Yeah, absolutely. So we're designing 3 all-electric zero net energy manufactured homes in California that exceed the energy and fire safety standards set out by the federal standard HUD. Little known fact is manufactured housing falls out of the jurisdiction of state and local energy codes. And the last time it was meaningfully updated was in the 1990s. So it's out of date. And it also means that this sector falls out of the charted journey, so to speak, of the state of California towards a zero net energy standard. So a little bit about manufactured housing and why should you care is these homes are 3 to 4 times cheaper to build than site-built homes, not including land. And they constitute almost 10% of new housing starts in the country. And that number is growing with the need for more affordable housing. And but at the same time, these homes are not only less efficient, they also have less robust fire safety standards than site-built homes. So that increases their carbon footprint, their costs, and their vulnerability for some folks that can really least afford it. And so within California, of course, we've had our fair share of wildfires. Unfortunately, there's an affordable housing crisis. And that's pushed a lot of lower income working class Californians out of urban areas into more wildfire prone areas. And so just to give you an example, the Paradise Fire that happened in late 2018 destroyed thousands of manufactured homes. So our goal with this project, which is funded by the state of California, was to address a very cost-sensitive segment and to develop a cost-effective, scalable model for these homes to not only decarbonize, but to become more resilient, specifically against wildfires in particular. And so what we'd like to see is we'd like to leverage the factory production efficiencies to essentially develop a model to broaden the accessibility of these solutions. And so we worked with a fabricator that's responsible for half the annual production in the country, Clayton. And we also have some engagement with HUD, which sets the standard for this sector, and as well as the state of California. And so the idea is to transmit our recommendations directly to them so that they can address gaps in codes and standards, programs, et cetera. And so regarding what we did, with the fire safety aspects is the HUD standard as it stands today primarily addresses the interior of the building, but it doesn't address the building enclosure. So our goal was to target a 2-hour fire resistance rating. That means it takes 2 hours for the structural integrity of the enclosure to be compromised. And just some of the measures we included were, Class A fiberglass shingles, pop vents with wire mesh screens, fiber cement siding, which is fire resistant, tampered glass windows. These are just to name a few of the things. But the goal is that these prototype homes will come off the line with an increased level of fire resistance while still remaining amenable to manufacturers' supply chains, which means that the first cost remains low, which is very important with this sector. So yeah, I hope that gives you a little flavor of one of the active demonstrations we have that specifically addresses this resilience theme of wildfire.
That's great. Well, thank you both for joining, and Erik for sharing your story, and Agatha for sharing some similar research that we're working on this space. Before we depart, Erik, is there anything you'd like to leave with our listeners?
Yeah, I think to me, the big thing I think is that these wildfires are happening, and they're happening all over in kind of different ways. We don't live in. I mean, I can see the mountains from the house, but we don't live in the mountains. We don't have trees. We were in the suburbs, and it was also December 30th. If you thought 10, 20 years ago you'd get a fire in the winter time when in Colorado there should be a lot of snow. Our home was not prepared for it, and any other home hit was not prepared for it. So just very excited about kind of bringing EPRI initiatives into kind of my personal life, climate change causing these types of events, climate adaptation, with fire resilience, climate change mitigation by, going low energy and electric only, electrification, and even trying to tie it a little bit to what I do with, power system reliability and customer resilience, which kind of links to some of the things I focus on from a research side. Get like that whole story with not being affected, significantly by the losing power in the middle of winter. If you had sort of an event like we did in Texas, in 2021, we'd have all of our neighbors come into our house, which would actually make the house warmer. So sort of amplifying that. So yeah, just, excited about kind of all these new things and learning about them more, and hoping to share the story with other folks to show how valuable it can be.
Thanks, Erik. Agatha, do you have anything you'd like to leave with our listeners?
The goal with our demonstrations, like the manufactured housing prototypes, is really to broaden the exposure to solutions that are proven and cost effective, and to thereby make the decarbonization transition more equitable and accessible for larger swaths of people. And where our research attempts to make sure that our results translate into clear codes and standards opportunities, market transfer, and program recommendations for key market players like governments, utilities, and industry players. So that's the goal from our end, is to really push for mass market solutions, which really advance the accessibility of these decarbonization and resiliency solutions.
Great. Well, again, thank you both for joining and for sharing both personal story and the research going on here at EPRI. And to our listeners, thanks for joining us again, and stay tuned for our next episode. That's it for us.
If you like today's show, we invite you to subscribe to our podcast, and feel free to share the podcast with your colleagues and friends. For more information about EPRI, please visit our website at www.epri.com. And don't forget to follow us on LinkedIn and Twitter at EPRI News. Together, we are shaping the future of energy.